So, hello, let's see another problem on bit manipulation. So, question given is given a number n, find the length of the longest consecutive ones in the binary representation. So, input format, the first line contain a single integer t, the next t line contain a single integer each representing n. So, let's see. So, let's take a example of input test case. So, we take number 3. So how it is represented in binary 1101 1101. So we have to check the number of consecutive ones. So let's see, the here is consecutive ones, maximum is 2, it is 1, so the output will be 2. Let's see another example. Suppose we have a binary number 101 triple 1 0 1 0. Suppose this is the number, so the maximum consecutive ones is 3. So how can we find number of consecutive ones? So let's see. The first of all we do basic method, which is if we do right shifting operation by 1 and check the left significant bit whether it is set or not. Okay, if it is set and the next bit is also set, then we increase the counter, otherwise counter will be increased, otherwise counter will be equal to 0. So let's see how it is work. First of all we have the number binary representation. First of all we check the least significant bit is set or not by number ampersand 1. From this we see that if the least significant is 1, it is set, then the output will be 1. We increase the counter, these two statement, if equal to 1, if we found that number ampersand 1 equal to 1, else if is equal to 0. So if it is equal to 1, we increase the counter plus 1 and taking maximum of that, maximum of max of maxi and counter, simple. And what is counter? Counter will be equal to 0 and maxi is set to equal to -1. If it is found 0, then we will counter set to be equal to 0 again. So let's try run this code. So what is the least significant bit of 101 It is 1, so it is set. So we will increase our counter, now it is 1. Now we will again left shift for this, if it is called number is equal to number is equal to number right shift by 1, again it comes to this place, again it's come to this place, again it will run. So let's try run this code. So if counter equal to 1, then we will left shift it by 1, so left shifting, so we will get a number, it is for 101, now 110. So again we do ampersand 1, we will get 0, so counter again equal to 0. Here maxi equal to 1, here counter again equal to 0. Again we will do right shift operation 1100. Again we will do ampersand 1, it will gain 1, again our counter will be equal to 1. our maximum is already 1, so no changes in that. Again we right shift, so it comes to 0 0 1. Again our counter will increase, counter equal to 2, maximum equal to 1. So this is the uh, native, basically native method. So what is the time complexity of this? uh, Length of the binary number. So what will be the length? It is 4, so the time complexity is big of 4. So basically it depends on the length of the binary number, length of the bin number. Simple. Okay. How can we optimize this? So we have to optimize. Let's see another example. Suppose let's work on the same example. Binary representation of 13 will be 1101. So we have to check, we have to perform an operation and ampersand and right shift by 1. What will it do? Basically 1101, it will right shift all the bits so that we can get 0 1 1 0. So we do ampersand and operation, so it will get 0, it will give 0, it will give 1, it gives 0. Again we right shift this bit, so what will we get? It will all 0. So what is this? Basically we are moving every bit so that we count, so till it is equal to 0, till it is equal to 0 we are moving bits. So how can it calculate the maximum consecutive ones? So basically suppose we have a number given as 10111011. Suppose this is our number. Let's remove this, and suppose this is our number 10111011. So we do a right shift operation and do AND operation with it. So we do right shift operation. So what will it? 1 0 1 1 1 0 1 0. So what will it give? It will give 1, it gives 0 0 1 1 0 0 0. Simple. Again we will do right shift operation, 1 0 0 1 1 0 0, all zeros, all zeros. Again do AND operation, it will give 0, it will give 0, it will give 0, it will give 1, it will 0, it gives 0 0 0. Again we will do right shift, because it is not equal to 0, it containing 1. So again we will do right shift operation till it becomes 0 0 1 0 0. So it all become 0, so it is equal to 0. Now we will stop. So how? If we check number of operation we have done till it is equal to 0, so it will check it is 1, it is 2, it is 3. So the number of maximum number of set bits, longest consecutive set bits is 3. So from this we can find longest consecutive ones in a binary representation. So let's code it. First of all, declare the header file, uh, studio.h, and hash include studio. We are coding in C, so int main, sorry, int main. We have to uh, declare a variable int n, int t, and number. Scanf ampersand t, copy and again paste it, ampersand t, comma ampersand NUM number. Simple. Taking all the input. Now what we have to do, we have to run while loop because we have t test cases. So that, so now in while we have to take in counter variable which will count our maximum number of longest consecutive one, while our number is greater than 0, not equal to. Be careful, we have not make it equal to. If it will be equal to, then it will run infinitely. So inside while loop we have to increase the counter and setting number equal to number ampersand and operation number right shifting by 1. That's all. Now we can printf this statement. Answer will be ampersand d. We have a counter variable. It is for the counting longest consecutive ones. Counter and close it. We have not declared the counter. Okay, we have to declare outside. No, it is right. We have to print it inside after every printf. We have to print answer will be ampersand d counter. That's all. Let's run it. uh, so let's check. Answer 1, nope. Let's wait a minute, let's run into Sublime. Let's check. Copy this function, copy. Wait a second. So let's run in Sublime. So let's check it. This is the input. So let's run. It is giving 0 by, oh okay, I got it. Basically we have to take input inside the while loop. Here it's some number. Now check 22234. Now let's check in the output. 22234. Yep, we are getting same output. So thank you. This is the main code. Okay.